getting back to your last exam there. I'm going to spend a few minutes just talking about final exam stuff, and then we'll get out of here early probably today. All right. So to remind, and I'll remind again when we're done as well. Hope has review today and Sunday.
Yep.
2 to 4 today, 2:30 to 4:30.
Today is right after class until 2.
Oh, right after class until 2. Okay. In the math center, and then 1 to 3 on Sunday. Is that right?
Yes.
Yes.
Yep.
Okay. So right after class until 2 today. Hope has review as well as on Sunday from 1 to 3, and Professor R time, our professional tutor, has hours on tomorrow from 10 to 3. So got lots of resources. I sent an email about it out yesterday as well to remind. But also on Moodle, I have posted a couple of reviews with solutions as well as I went back through your exams and posted blank copies if you want to work back through them, and then specified what numbers to look at on the exams from the previous ones. Okay. So basically, just wanted to kind of go through each of those and remind you about the topics that I'm talking about on those. So on the first one, we have 2, 3, and 8. And if it'll zoom in for me here. Yes, great. Make sure you open all sorts of things that I don't care about. All right. So problem number 2 here. Remembering about finding domain of a function. So big things that we had to worry about domain. What were kind of the 3 big things that we had to worry about? What's one thing?
Can't root a negative.
Yeah, can't root a negative, so that one's in this one, right? What else?
Can't divide by 0.
Can't divide by 0. That's also in this one. With respect to logarithmic functions, what can't you take the log of? That was kind of a third one we had for domain issues. What can you take the log of? Well, I'm asking. Okay, let me ask you this. What does your exponential function graph look like? Start there.
0, 1.
So remember, we either went up and to the right or down and to the right? But it was always above the x-axis, right? We had that horizontal asymptote. Logarithms are inverses of exponentials, right? So if the range is 0 to infinity for the exponential, always above the x-axis, what's the domain for a logarithmic function? Range of the original equals what for the inverse? Domain, right? So if the range for the exponential is 0 to infinity, what's the domain for a logarithmic function? 0 to infinity, so we can't take log of zeros and you can't take logs of negatives, right? So that's another domain question that could get asked, right? So those are the 3 big domain issues that we have, right? I'll write them down here. Domain issues. Divide by 0 is 1. Square root of a negative. Right? And then logs of 0 or negatives. Okay. Those are domain issues that pop up. Those are kind of the 3 big ones. All right, so that's what number 2 here was talking about. Number 2 basically combines the first 2 problems, right? We've got this expression in the denominator, so it can't be equal to 0, and we also can't have the negative under the square root, so you have to make sure it's strictly positive in that case. Third one was that difference quotient idea. Remembering how to simplify something that was asking you to do a difference quotient. Zoom in a little bit more so we can actually see it a little bit better. And remember, again, all these answer keys for these exams are on there too. But the reason why I put the blank ones on there is you might want to work through them and then go check the answer, right? Okay. So we'll make sure to put the blank ones on there. All right, so difference quotient again. Remember, this does not mean add h to the end, right? It means take out the x and put in the whole a plus h in for x, right? And then simplify. And then also on this exam, number 8, scroll here. Remember we did, whoa, that was fun. Remember we did all of those transformations of graphs, right? Let's just go through from left to right here and remind ourselves of what each one does. A negative out in front on the outside of the function does what? It flips it x-axis, right? Top, bottom, right? A number here out in front does what? Yeah, stretch or compress in the case in the y direction, right? Right. So this one's going to flip around the x-axis. It'll stretch by a factor of 3. Coming on the inside, what happens when you add or subtract in there? Yeah, where's right or left? In this case, we'll move to the left because it's +1, right? So left 1. And on the outside, the +2 will go up 2, right? So when we do add and subtracting, it shifts. And on the inside of the function, it kind of does the opposite of what you think it should, right? All right, so making sure that you're able to know how to do those transformations, especially being able to list them out, right? We've done ones like that before. Any questions on those 3 types of problems at all? Let's go back here and pull up the next one. This one says all questions. Let's see what's going on with this one. Okay. Oh my, why do you have to open up 10 things when you open up a document? Okay. I want to see the document. And the first one here, remember it's trying to recognize a composition, looking for an inside and an outside idea, right? We did ones like these before. So one way to do this would be let your h of x be that x squared plus 7 idea there, right? That's kind of the inside. And then your outside would be -2 cube root of x minus 3. So when you use the composition. The next one is just doing your function arithmetic stuff. When I just write f times g here, that part there, that means multiply, right? So you would plug 4 into f, you would plug 4 into g, and you would multiply the 2 answers. Versus when I write the f circle g, that's composition, right? So the first one, just to write it down here. Again, this is more of a reminding of what's going on with these things. But if we write f times g of 4, that means do f of 4 times g of 4. When you write f circle g of -1, that means do f of g of -1, right? That's not multiplication. Right, that's composition. Also, remember we did inverse functions. What do you do to start? What do you start with by finding an inverse function? What do you have to do first? You flip the x's and y's, right? We think of y being the g of x, right? So you start with y equals 4x plus 1 over 2x minus 7, and then flip-flop your x's and y's, right? Make your y x and make your x's y, and then solve. So if we just started that one, you would start with, again, y equals 4x plus 1 over 2x minus 7. And then, again, you would just flip-flop everything. That way. And then you have to clear your fraction and distribute and gather and refactor. We did ones like that before. I like this type of problem, just as a hint. Might be a hint that something like that might be on there. Okay. And it's not so much about finding the inverse of this specific type of function. This idea of being able to gather and refactor is comes up a lot in math. That's why I like this particular type of problem, because the concept pops up later. We also did polynomial long division. That's what this one's an example of, right? We divide the numerator by the denominator. Go through those individual pieces. So remember, the first thing that you would ask yourself is, what do I need to multiply x squared by to give you 5x cubed? That'll be the first step. Then subtract down and scaffold. Do it kind of like what you did long division back in grade school. Same kind of concept. This one here, how do you find the degree again? What do you look for finding the degree of a thing that's a polynomial written this way? So the highest exponent would be after you multiply, right, out. So what would I do with these exponents, though, on the factors? What would you do with them to find the degree for this one? Yeah, we add them together, right? The 1 plus the 4 plus the 2. Okay. And again, the degree tells you something about end behavior, right? Since the 7 is odd, do the tails point the same direction or opposite directions? Opposite, right? So either is this way or this way, right? Lower left to upper right, or upper left to lower right. And then asking other different types of parts of that particular question. Just going through and making sure we know those things. What would be the leading coefficient in this one? The -5, right? That number that's here out in front. That I'm pointing at, you can't see because it's not it's not showing anything on the screen. End behavior then, since it was negative, does it go from lower left to upper right, or vice versa? This way, right? Upper left to lower right, because it's flipped upside down. Just flip my hands around like a robot. All right. So that would be how we do those end behavior ones. How do you find y-intercept again? Yeah, but the 0 in for x, right? The x-intercepts we should be able to read off since it's factored, right? Multiplicity refers to what again?
How many times you see it?
Say it again.
How many times you see it?
Okay, so what would be so in this case, we would look at those powers on the on the factors, right? So we'd have a multiplicity of 1 for that one, 4 for that one, and 2 for that one, right? And then the multiplicities tell you whether it crosses or touches, right? Odd multiplicity crosses, even multiplicity touches, and all those good things. All right. Let's look at the next one. Writing a quadratic function in standard form. Remember again, the first thing we would do, factor out that -2 off of that piece, right? Off the x's. You get a coefficient of 1 on the x squared. Ooh, I can pick up the chalk. So the completing the square part comes in at this stage, right? What do we need to add inside here to complete the square? What do you do with this coefficient? Do you remember? Divide it by 2 and then square it, right? Divided by 2 is 3, squared is 9, so I'd add a +9 in here, right? If I add a 9, does that keep everything equal? No, okay? So I also need to subtract a 9, but I also need to make sure that I multiply by that -2 that's out in front, right? And I believe Hope taught that, didn't you? Yeah, I remember. So that was our big technique for doing completing the square, right? We also had the shortcut way to get at the vertex. Do you remember what the shortcut way was? It was a fraction of some sort. Yeah, it's a negative b over 2a, right? Now, that gives us the x coordinate, or in this problem, it'd be the t coordinate of your vertex. How do you find the y coordinate after you find this value? Plug it in, right? We just take it and plug it into the function. This is our shortcut method. This should also look familiar. What's your quadratic formula look like?
Plus or minus the square root of b squared minus 4ac.
Yep. Yeah, all over 2a. Notice that minus b over 2a is in there too, isn't it? It pops up there as well. The reason why it pops up in there is because if you think about what happens with a graph of a quadratic, that expression tells you where you cross the x-axis, right? And your vertex has to be halfway in between. That's where that minus b over 2a, that's why that's in there. So anyway, just trying to relate those two ideas. You don't have to remember that at all. And then last one here, listing out possible rational zeros. What do you look for possible rational zeros? There's two numbers you look at first for possible rational zeros.
Degree and constant.
Yep. Yep, we'll look at the leading coefficient and the constant. We do factors of the constant and factors of the leading coefficient and divide. That's what gives us the possible rational zeros, right? And then at this point, you would pick ones that you would think work. Looking at this, it looks like negative 4 and 1/3 would work. And then you use your synthetic division to break it down. We also did complex zeros, right? And remember, if a plus bi is a 0, what else has to be a 0? If you have a plus bi is a 0, what else has to be a 0? A minus bi, right? The conjugate. That was all the stuff that was on test 2. Lots of stuff on test 2. Test 3. We also did rational functions. What do you look at for a rational function for where it crosses the x-axis? Which piece do you look at? You look for x-intercept, which piece is important? The numerator, right? So if the numerator equal to 0, that tells you x-intercept, right? Then if you wanted to do vertical asymptote, what are you looking for? The denominator being 0. Good. So numerator 0 is x-intercept. Denominator equals 0 is your vertical asymptote. We already talked about how to find a y-intercept. You plug in 0 for x, right? Horizontal asymptote, we look at the degree of the top and the bottom, right? If they're the same, we did that ratio of leading coefficients. So in that case, you would have 3 in this case. And then we put all those pieces together to be able to graph it. I also told you, look at 4. So 4 is about breaking up logarithms using the properties. If you have a log of a product, how can you rewrite it? If it's a product, it turns into a sum. So if it's a quotient, it turns into a difference, right? And if you have a power, what can you do with the power? If you have a power on the inside, what can you do with the power? Bring it out in front, right? Those are the big ones. So in this case, the first thing you would do is rewrite that as a 1/3 and bring the 1/3 down in front. That would be step 1. So don't forget about your log properties. They're important. And then this is the same idea, right? And this is just a matter of remembering how to rewrite things as logarithms or exponential in equivalent exponential form and rewriting things. And then 6 is all about solving equations. We had one way we solved exponential equations was to get the same base on both sides. What base might you use for that one, for the first one here? What base might be a good one to use? 5 in this case, right? Because 25 is 5 squared, and 125 is 5 cubed. If you can't get the same base, what's our big plan of attack to get those x's out of the exponent? Yeah, take it a log, right? Take a log so you can bring them down, right? Take the log of both sides. And then the other ones were about using log properties, right? So in that one, you'd make a quotient because I've got a difference of the logs. And in the next one, you would make a product because you got a sum of the logs. And then finally, your last exam here. Told you to look at 4, 6, and 7 on this one. Well, 4 is solving a system using Gauss-Jordan. There we go. It's a little bit bigger. 6 is being able to find an inverse using Gauss-Jordan and then using the inverse method to solve the system. And then 7 was your nonlinear system. So that was on that test. So again, those are the ones that I would focus back on. You should be able to find problems similar to those on old reviews as well. Plus, you've got 2 new review sheets. Okay, so you got lots of practice problems to be able to do. You've also got Hope. Again, she's going to be in the Math Center from today till, say, 2 or 2:30. 2. She'll be in the Math Center till 2 today for review, and Sunday from 1 to 3. That one I remembered. Any questions at all? No questions? All right. You can always email me over the weekend as well. 10 o'clock Monday is the final in here. But otherwise, have a good one. We'll see you then.